Hello everybody. I want to tell you about a little project I've been working on. As you know, a little bit earlier in the year I did the computer controlled Christmas lights, and I'm continuing to work on that project by instead of just having Christmas lights that turn off and on, I'm working on the ability to dim the lights and give different levels of illumination to each individual light that's hooked up. What I've had to do is I've had to go through and use a different microprocessor to make that happen. I was using a basic stamp microprocessor, which isn't very fast and doesn't have a whole lot of features to it. And what I decided to do is go with the next processor up that's available from the company that makes the basic stamp, and go with their Propeller product. It's a really cool little microprocessor that has 8 individual cores in it, and it has 28 general purpose I/O lines. The basic stamp only had 16 general purpose I/O lines, and this gives me a whole lot more flexibility because I have more lines to be able to do stuff with. In order to get it to work, I had to start doing assembly language on the microprocessor, which I've dealt with assembly many years ago and haven't looked at it since. So basically I had to relearn everything, and probably know more about it now than I did at the time whenever I was learning it. But it's been an adventure so far. Here's my little test rig that I have set up, and here's our little microprocessor. In order to be able to dim, what I have to do is I have to have this little circuit over here, and what this little chip does is it's hooked up to a little wall wart transformer right there that converts the wall current down to about 10 volts. And what this little guy does is he waits for the AC signal to cross zero. Basically you have a positive waveform and a negative waveform in an AC circuit. Whenever that crossover occurs, it makes this little line go low so that the microprocessor knows when that happens. Over here I've got this little guy, and he is our triac, which is basically sort of a solid state relay. And interesting thing about triacs is whenever the triac is turned on during that AC waveform, it continues to stay on all the way through the end of the cycle. And if you don't turn it on again for the next cycle, it will remain off. If you turn it on halfway through the cycle, you're able to basically get dim lights, which is what I have here. I have a set of Christmas lights set up, and they are dim. If you look at the voltage that's going to them, it's about 30 volts. And up here on my scope, you can see here's our AC waveform, and here's where the triac's being turned on. It's about, I don't know, I'd say 3/4 of the way, or maybe 2/3 of the way through the waveform, with it being turned off through this period. It gets turned on here, so basically this part of the waveform is the only part that is actually flowing through our lights there. Now that doesn't sound like a big complicated deal, and that was relatively easy to get going. Now what's going to be difficult is actually configuring it so that you can do this with multiple circuits. And with my assembly program, if I don't shock myself here, I'm going to show you another output pin that I have configured. I didn't change any software or anything. It's set up, and while the other one was a solid dim, this one is making it go bright and dim. And you can see the voltages jump up and fall down, and then jump back up again and then fall down. And if we look on our scope here, you can see where that line turns on and off through the waveform there. That would be fully eliminated. That would be completely dim. That would be fully eliminated again. And let me kind of hold this up here so you can see that action. So that's what I've been working on. It's kind of crazy stuff, but it's really cool. I don't know, hopefully I'll be able to have some really cool stuff ready for Halloween. Anyway, you guys take care, and hope you enjoyed the video. Bye.